All right, go ahead and please introduce yourself, and you have the floor.
Perfect. So thank you, Tammy. Thank you, everyone, for joining this presentation. So I'm Ilyes Yousfi. I'm Senior Key Account Manager at the Reuse company. And today's topic will be dealing with the project data dictionaries and why we should consider them a choice piece when it's time to comply with the INCOSE guide to writing requirements. So the content basically will be first to discuss a little bit about the Reuse company, a brief introduction of what we do, and also uh, how we do tackle these aspects of project data dictionaries. And then we will focus on the reasons why these project data dictionaries are important. Also define what a project data dictionary is, and also put it in the context of the of the um, of the definition of needs and requirements, and also link it, of course, to the INCOSE guide to writing requirements. Then we will ask ourselves, what are the differences between needs and requirements, and also some tips about how to distinguish them from the tool-aided perspective, which is the next point that I will be covering. So how to assess automatically the needs and requirements following the INCOSE guide to writing requirements. Here it will be just a recap from what we already presented in previous events. So I will reference to the previous events we had dealing with this topic. And then I will finally present what is the input that we would like to suggest to the INCOSE guide to writing requirements, which is the rule applicability matrix, which in a nutshell presents in which cases we do suggest to use the rules for needs and for requirements, and also if there's a need for a project data dictionary to support the assessment of the rule. And then finally, I will go through some quick examples in a demo, and then we'll have time for questions. So let's first have some facts about the Reuse company, just briefly. So we've been established in 1999 as a spin-off of a university in Madrid, with people combining systems and software engineering skills. Also strong combination so between the company-driven activities and the innovation that comes from the university. So dealing with the development of new capabilities in our solutions. The headquarters are based in Madrid, and we have also some international offices around the world. And here, in a nutshell, what would be the mission here? I will be doing another recap later in this introduction, but basically it is about dealing with the reusability and the adaptability of the solutions to a specific environment, to a specific industry, to a specific knowledge activity. So always using the knowledge as a center of the of the systems engineering processes. So instead of dealing with a document-centric approach, we would like to move to a knowledge-centric approach. And then here just a view of the office, where we are located, and also where the customer base is located, and some facts and numbers here about the company. So here just for you to get the idea. And another way to that we're usually named, so the Reuse company is TRC, just the acronym, which is also the three main pillars that we use in the domain of requirements engineering. So traceability, quality, of course, dealing with the INCOSE guide to writing requirements, and the reusability of the knowledge and of the created artifacts. And this is what would be the summary of our activities in general. So generally speaking, the application of semantic technology, so powered by NLP and artificial intelligence, and the digitalization of the processes throughout the systems engineering lifecycle. So let's answer the main question of this presentation, which is why using a project data dictionary, especially in when dealing with the definition of needs and requirements in a system engineering project. So first, we will ask ourselves what a project data dictionary is. So there's a definition that I'm using here, which is coming from the IBM Dictionary of Computing, which is mentioning the notion of repository of information. So storing data such as the meaning of the terminology we'll be using, the relationships to other data or other concepts, the origin, the usage, and the format. So everything that has to deal with this kind of data is centralized in what we call a data dictionary. So this is usually something that we would define at organization level. So everyone in an organization, we share the same understanding of concepts. We have the same way to name some domain specific concepts. And here we will ask ourselves, so the notion of project data dictionary, so which is, let's say, the tailoring of this organization-wide data dictionary to a specific project. So we have always these two levels working together in the definition of the system engineering processes. If we relate, for example, to the system engineering handbook, we have the organization-wide levels, and we have the project-wide activities that rely on these infrastructures that we have at organization level. And we have to adapt these resources, this information, and these processes to the specific project. So if we focus on the needs and requirement definition field, we would define the project data dictionary as across the team an agreed upon set of standards and guidelines which would enforce the use of a common vocabulary, a common set of concepts. And the objective of that is to ensure the consistency of needs and requirements for all the project team members, also the stakeholders involved, and to make sure that we all get the same idea of what we are describing. So it's mainly a communication aspect, and also a good way to have a consistent information throughout the life cycle. So when we speak about project data dictionary, we in fact speak about the foundations. So of course, everything starts with data that are spread across different sources, across different teams, maybe across different organizations, different countries. So this data then is being processed and converted into information. So we start describing this data, we start linking information then and produce knowledge. So when we are dealing with system engineering activities, we do want to place ourselves in this at this level. So the concept of project data dictionary here is also emphasizing the fact that this PDD, as I will call it later in the presentation sometimes, is the foundation for a good knowledge management approach. So remember that in the processes that drive the development of the system, we have a very important process, which is the knowledge management process, which is supporting most of the processes here at organization and project level. And this knowledge management, together with the information management process, help making decisions throughout the life cycle, help mitigating the risks, and so on. So we need a good knowledge management process, and everything starts with a good project data dictionary. So we need to gather this data, we need to store this data and share, then process this data to create knowledge, and then share and spread this knowledge across the appropriate teams and projects. So if we look at the reasons why we do need a project data dictionary, so why would we have this centralized repository? Why would we define guidelines, concepts to understand the data? So I will be exaggerating a little bit here with the examples I will be taking. And then let's imagine what happens if we are dealing with thousands of complex concepts, complex functions, and so on. So we would start with something very simple. So I really like the multicultural aspects of engineering teams. So working with teams in different parts of the globe, and sometimes if we do not define appropriately some of the formats or some of the guidelines we would like to use to define our concepts, then we might end up with these kind of situations. So this looks like a date. That's obvious for everyone, but how do I understand that? And this depends on different factors: where you live, where you do live, in which countries, if you live in Europe, if you live in the UK, if you live in the US. So we have different aspects. So what is the decision? So this depends on the format that we decide. And of course, this could get even worse, because if I write this that way, then we don't even know where the year and where the day is. So, and if I take another example, speaking about international teams, we often use acronyms throughout projects, and even between different teams. So this is something we know, everyone knows. And if you speak one of those languages here, apart from English, then you know we're talking about the same thing. But what if we work with different teams and we don't know what this acronym means in the other language? So we all speak English, or at least we all practice English in our international activities. But if we have some knowledge, so some data that has been processed into knowledge that is using an acronym in another language, and we don't know what this acronym means, we might end up with ambiguous situations. So this is just to let you imagine the ambiguity that might be introduced while dealing with systems, and especially complex systems with, as I said, thousands of functions, thousands of actors, of components, if we don't pay attention to these details. So basically, the project data dictionary is introducing a consistent wording. So with the help of subject matter experts, which helps extending the coverage of the INCOSE guide to writing requirement set of rules, because most of the rules, or let's say various of the rules at least, require a dictionary to be assessed. This is the result of the rule applicability matrix that we've been drafting. So some of the rules are mentioning the consistent use of terms and acronyms, the fact that you have to define the right subject at the right level, and so on. So this needs requires a project data dictionary to be let's say to be able to assess this rule. And also this helps defining a standardized way of drafting requirements. So this helps when we draft requirements with a standardized way. This helps performing traceability, either manually or based on algorithms powered by the NLP, natural language processing. This helps reusing the requirements. Of course, if we have a standardized way to write the requirements, we know where the subject is. If the subject changes because we have a deprecated version of our component and the new one is named differently, then we can identify where to perform the change. And we also can identify with more accuracy the redundance, the duplicated or contradictory requirements or needs that might be found in the specifications. And I might also recall the presentation that was held at this same event, the pre-IW last year, about the need for, let's say, the importance of ontologies to guarantee a single source of truth throughout the life cycles. So if you're interested, just follow the link here. It's also in the channel of the INCOSE requirements working group on YouTube. And so if we close let's say this introduction about project data dictionaries, and we talk about the let's say the benefits regarding the communication. These project data dictionaries help having a universal interpretation and expression of things. So that's very important, especially across teams that have different profiles, different skills, different experience, and also the accessibility of the textual form of communication is, of course, higher than the use of any modeling language, uh, uh, especially when we want to target a broader public of stakeholders. So, of course, the same way we have to define guidelines for the textual form of communication, we need to agree on the modeling language we use. So that's applicable to all forms of communication. But if we don't apply it to the textual form of communication, which is the main one used by the human stakeholders, then we might end up with critical situations in terms of ambiguity and misunderstanding. So let's now um, ask ourselves, so what would be the difference between needs and requirements? So how should we characterize and distinguish needs from requirements? So let's first list some facts about needs and requirements. So um, the first thing we have to take into account is the importance of what we call the tailoring space. So when presenting our approach to tailoring the INCOSE guide to writing requirements, we introduced the notion of tailoring space, which is a three-dimensional space. I will get to it later. It's going to appear later in the presentation. So we have three different dimensions to consider the tailoring of these rules, and in general, the way we should with which we should assess the quality of requirements of needs of any work products. So the thoroughness of the rules to apply depend on these three dimensions. And there's another let's say aspect that has been used in the section 1.8 of the INCOSE guide to writing requirements, which drew our attention, which is the use of tools to address both needs and requirement statements. So you would like to assess both using the rules, but more importantly, we want to understand the differences between the two. So how do we understand the difference between needs and requirements? So we've had some interesting inputs from the previous presentation about what is a need and what is a requirement, but then we have to understand the differences, and sometimes it's not that easy to determine. So addressing both is something that has been more or less covered by most of the tools that tackle the assessment of needs and requirement statements. But how do we tackle the difference, and how do we understand the differences? So when we talk about NLP or semantic technology, this is an extra feature that would help understand the natural language, apart from attributes, which in our opinion is not enough to characterize a need and requirements. Because one would think, okay, so if I want to assess a need, the quality of a need, so is it correctly written, following the rules from the guide to writing requirements? So I would just say, okay, so I will have an attribute that says this is a need or this is a requirement, but that attribute might be changed over time, maybe mistakenly. So we don't know if this it's certainly not enough to make sure that the statement that is written is a need or a requirement. And also because within the requirements category, we have several kinds of requirements. We have functional requirements, non-functional requirements, safety requirements. So they have also their aspects with regards to rules to apply. So attributes might be part of the answer, but they're not enough to characterize this. So we have to use other means to understand the natural language, and the data dictionary is key, of course, to define these structures, these terms or acronyms that will be helpful to understand the natural language. So not only is it is a help for the communication between teams and between organizations, but it's also an input for the such tools that rely on NLP or semantic technologies. So we would allow, for example, the use of some structures in one case and not the other. So we will see some examples later in the presentation. And also one aspect is that we would like to implement the rules following the appropriate thoroughness based on all these inputs. So if we want to rate needs and requirements from the quality point of view appropriately, we need to have this in mind. And then if we look at the difference, so this is taken from the INCOSE guide to writing requirements here. If we look at the difference, so apparently if we look at this diagram here, this entity relationship diagram, apart from the fact that we have validation attributes included in the needs, whereas we have verification attributes included in the requirements, and the fact that this is a need and this is a requirement, what makes those two objects so different? So the first thing is, of course, as I said, the fact that they're not having the same purpose. If we think about the VMV aspect, so needs are transformed into requirements. So basically, they're not pursuing the same objective. But more importantly, we have rules here, and the rules that are linked to the characteristics will not be the same. So if we look at the three-dimensional tailoring space that I was mentioning earlier, so we would have different levels of details if we consider business requirement specifications or stakeholder requirement specifications compared with system requirements. We would have, of course, in different life cycle stages. So since we are talking about the design of complex systems, we would have different iterations. So the level of detail would be increased. Also the status in the life cycle, and of course the criticality. The higher the criticality, the more thorough the rules would be. So if we focus on needs and requirements, we might say that we design needs here and requirements at different stages. So the rules would be more strict as we go through the definition of needs or requirements, and we have some loops, so the iterations that we have to take into account. So it's always a progressive approach. So this would be, for example, needs, and this requirements, or the opposite. So we would have here to decide what set of rules to use. So this is the theory, of course, and then I will show you the rule applicability matrix with some examples. So this is what we would have as a nutshell. So the rules for needs would be a subset of the rules used for requirements. So different purposes. So as I said, needs are defined to define what is needed to meet the business expectations, whereas requirements are the things we need to achieve these needs. So what features, what functions we have to specify. So the requirements translate needs. So they are derived requirements. So that's why in the thoroughness they should have more metrics, let's say, or rules to assess them. And of course, the rules that apply to needs would obviously apply to requirements. So if I don't allow the use of a vague term in the needs, of course, I'm not allowing it on requirements side. So, and usually one need derives into one or more requirements. So the rules that are needed for requirements are more thorough, and the rules would be based on so the applicability is defined. So what are the characteristics that make this gap here between the needs and the requirements? So that's what we call the rule applicability for needs and requirements. So now I will be doing a quick recap of the needs and requirements assessment and how it is automated in our solutions. So we did start from the last version of INCOSE, the INCOSE guide to writing requirements. So of course this will be updated as soon as we have the new version of the rules published. So we started from the let's say the model defined by the guide with the characteristics, the underlying attributes of requirements, and the rules to assess and how to formulate the needs and requirements. And we ended up with two additional, let's say, dimensions apart from these three given by the guide. So each rule is implemented by one or more metric, which is defining how we should measure the how we should measure the characteristic or the aspect covered by the rule. So for example, how do I measure the fact that I have defined a vague term? So in that case, it would be as simple as counting the, the number of vague terms. We can have exceptions based on the context. So that's where the NLP is involved. So understanding that I'm defining a condition, I can have multiple conditions separated by a combinator and or, which is not harmful in that case, whereas having and or separating various actions in the same requirement would be harmful for the atomicity of the requirement. So this is what the metric would do: count so quantify the characteristics defined in the underlying rules, and the quality function is counting and giving a result for this metric. And this is how we rate the requirements. So I will get to that during the demo. And so with which data do we perform this assessment? So how do we what input do we get to quantify these indicators? And these data come from the project data dictionary, as we would imagine. So define terms and acronyms, main terms with synonyms. So I can forbid the use of synonyms and only allow the main terms, so that no one can use another term that the main one. We can disambiguate two acronyms that have different meanings. So which one is the one used in this or that project? And if the project relies on the taxonomy, so let's say a system structure or a classification of life cycle stages of requirements, so anything that would be defined in a hierarchy that would create dependencies between the concepts. So the famous relationships between concepts that we were introducing at the beginning of the presentation, and other things that could come from models, ontologies, or other sources of knowledge. So we did have an extended presentation on how to tailor the INCOSE guide to writing requirements. So again, I'm putting the link here. I'm not going to detail how these rules have been implemented, but it's just here to give you an insight into the methodology and how this helps then in the definition of the rule applicability matrix. So this is what so based on the picture that we got from the current situation. So the fact that we mostly assess needs or requirements using the same set of rules, that we lack this tailoring to needs or requirements. We decided to suggest that some rules would be maybe in the early stages at least considered optional, or we would say better recommended for needs, and some rules would be compulsory. So we'll see how this applies to needs and requirements in some examples. But that means that sometimes when we write needs, we have to have a lower expectation if we compare that to the rules that are defined in the guide. So So we cannot apply the same set of rules to all the different objects at all stages of the life cycle for all the systems independently from the criticality and so on. So instead of just having this theoretized, we did come up with a practical approach, which could be used then to distinguish needs and requirements, not only helping the users distinguish them using NLP based technology, but also to have a different assessment. So to make sure that what I wrote is appropriate for a need or for a requirement. So we need this tailoring. So as you can see, this tailoring to needs or requirements would be considering the level of criticality and the life cycle stage. And the level of detail is going to have an impact on the need for a project data dictionary or not. So the less detailed I am, the less need I would have for a project data dictionary, because if I keep the concept very generic, this means I may be in a higher level if we speak about the V model, for example, defining business requirements, and I don't have the appropriate wording so far to define the dictionary. But then when I move down uh, through the V model, then I would need to be more accurate in the way we name the different elements of the system or the different functions. So it's asking ourselves if you want to assess cross-domain aspects like the syntax of the sentence or the use of vague terms that would be defined at organization level, or if you would like to check domain or project specific, in that case, aspects. So this also has let's say a meaning when we consider the evolution of the assessment of the quality. So we often uh, we often spread the idea that we need to be progressively moving from a small set of rules applied to objects like needs, and then move up, so scale up in the rule set until we reach a high level in terms of quality. So we will be assessing requirements with more thoroughness, and that's why and this thoroughness we need to assess the requirements will also be provided by the maturity of the project data dictionary. So the more information, so the more aspects we will be checking if it's a requirement, for example, or a subsystem requirement or a design requirement, the more input we will need from the project data dictionary. So then if we check the main content of the rule applicability matrix, so the first thing is a recap of the rule ID, name, and description. So just to be able to refer easily to the guide. Then you have the one of the main aspects, one of the first dimensions that we provide to these rules, which is the rule applicability. So here we have different values, let's say for this column in the table. The first one is what we call CNCR, which means that it's compulsory for needs and requirements. So here we don't make any difference between both. So the rule is applied to both equally without doing any tailoring. When we have RNCR, the R is for recommended, as mentioned in the introduction to this part. It's recommended for needs. So we would skip that rule at least when we are at early stages in the stakeholder needs definition, for example. And then we would progressively apply these rules to move smoothly to the requirements definition. And then in that case, we provide comments about the reason why we consider this is recommended. And in some of the cases, this is considered optional for needs. So it's another level. It's not just recommended. So this would be let's say changing over the stage the needs definition, whereas this one is clearly considered an optional aspect for needs. So the rule scope here is the other dimension, which is asking the question if this rule requires a project data dictionary, glossary, model, ontology. So these words are used several times in the guide. So here I focused on project data dictionary as a concept, but the format in which it is maintained, if it's just a glossary, if it's combining glossaries and models, if it's an ontology that gathers everything. So regardless of the format and the how extended, how developed the data dictionary is, this dimension is just defining if we require or not this information for the rule. So here, an example with the first two rules of the applicability of the guide. So for this applicability matrix. So first we have the rule one, which is a sentence structure. So use the form of a complete sentence. So it's checking that the structure is following a given pattern. So, and this applicability is here compulsory for both. So we don't want to have some elements skipped from the sentence. So we cannot allow, even if it's a need, we cannot allow the need to be without any verb or without any object. We need at least a subject, a verb, and an object. And that's why we consider this a compulsory for both. Whereas rule number two is considered a recommended rule for the needs and compulsory for requirements. So we don't allow, at least we don't, the guidance from the tool is not to allow any passive voice in requirements, whereas we recommend the use of passive of active voice for the needs. And here the comment or the elaboration for the needs is that the use of active voice can have a higher tolerance when considering needs, especially, for example, when we talk about user needs. We would start the sentence with the user shall, and then usually the user is receiving a service or let's say an object or something from the system. So that means that at this point the passive voice would be tolerated, but when we convert needs into requirements, we have to make sure that this is no longer expressed this way. So it's progressively moving to an active voice form. And so if we look at, so this is the elaboration, and if we look at the rule number one, we need a proper standardized structure, and the project data dictionary is not required here because this standardized structure could be defined at organization level. So that's at least the suggestion we have. So of course, if we have exchange of knowledge between different teams, if we have different structures between teams, then this is harder to implement. So that's why we would mainly have an organization-wide definition. So let's say of guidelines of agreed upon standard or process for this rule. Whereas rule number two here, even though it's not requiring project data dictionary because it's a generic syntax checking, relying on the check of the checking the language. So the passive voice expressed in English or in any other languages is checked the same regardless of the project, regardless of the system to be developed. So it's not relying on any project data dictionary. But here we might use passive voice as mentioned before, whereas requirements shall use active voice because we can easily identify the system of interest or the component if we have a lower level requirement considering the V model. How do we express the functionality? What system or system element is to be linked with that function? And as I said in the introduction, these structures and the use of the active voice help in the matters of traceability and reusability of the requirements. So now I will show you some examples of this rule applicability matrix. So with some rules that, so of course taken from the guide, with their related applicability and scope as defined in this matrix that we have been suggesting here to update the INCOSE guide to writing requirements. And in this example, we will focus on those 4 rules. So rule number 3, subject verb, which is the use of an appropriate subject at appropriate level. And if this is, let's say, a valid subject in the project. So of course, we rely on project data dictionary here to define what a meaningful and appropriate subject is. And this is expected in both cases in needs and requirements, because otherwise the people reading the requirements or the stakeholders will not be able to identify what we're talking about. Then one rule that comes along is the use of defined terms. So we can have a subject defined at appropriate level, but is the subject defined? Is there any possible ambiguity with this naming? Is it can it be referred to? Can it refer to another project or another component? So we have to ask ourselves these questions, and usually the project data dictionary has an answer for that, because we have a definition for each of the terms, the glossary. The correct spelling is also related, because it's in the name. We have a dictionary in there, so not only is it relying on the language dictionary, but we also have the ability to check if the terminology is already correctly spelled. So if we have a system name that has special characters, but this is a definition that has been provided in the dictionary, then we are capable of checking that as well. So the dictionary is, let's say, in a nutshell, the conjunction of the language dictionary and the project dictionary. So both can be so used. So it's a conjunction, so used together. And sometimes the language dictionary has one definition for the term, and the project dictionary has another. So we have to make sure that once we have these 2 terms, we have to make sure that the right one, the right meaning is intended. And finally, the acronym here is any abbreviation that we use in a project is obviously defined in the project data dictionary and is to be used either in needs or requirements. So for example, if I write this requirement, of course, if I'm not working in the project, or if I don't know what the project is, I have no idea what this means. So in either case, it's more than recommended to have this defined, because, as I said, this can be mistaken with another word or another concept. And every time we use acronyms, we have to be careful. So in that case, we would have all the rules here involved. So rule number 3, is it a valid subject? We don't know it. It's not defined. So it's not in the glossary. It's not the spelling is not correct, and it's not a defined acronym. So with one single term, we can have 4 rules involved at the same time. So that means that here we see in a basic example how a project data dictionary would solve this, because once I have this defined, then if I use, for example, NLP-based tool, I will come to the example afterwards. Then we might be able to check the definition or see what's happening. So this is what would happen if we write this the wrong way. So if I check the example in real time, so this is a requirement as as it was just shown. And if I write this, then you see that I'm writing and this is checking in real time. And in the end, these are the rules that will be popping up. So rule number 3, So it's not a recognized agent. So agent meaning here a system, entity, or any actor. And we don't have the term as classified. We don't have a correct spelling. And this is an unknown acronym. So these are the rules that are triggered. If we check this second example now, we will be involving rules that are recommended for needs and compulsory for requirements, which is the meaning of these RNCR here. And at the same time, not required, do not require a project data dictionary. So not requiring a project data dictionary doesn't mean that we cannot automate these rules. We'll see just after that, of course, relying on NLP-based tools, we can tackle these aspects at the same way we have to tackle with the project data dictionary rules, let's say, which was the previous example. So if I write this here, so when invited to enter user credentials, the user shall be notified by a large screen above 30 inches connected to the management system. If I write this, which apparently would be characterized as a need, here I have, if I consider the rules, the complete, let's say, catalog of rules from the guide, this is one aspect I would like to avoid. This is an article. So how many screens do I need to notify the user? Is it only one? Is it two? So if it's one, why not using one instead of the indefinite article? Large screen. Here, let's say that the expression between brackets is a kind of rationale. So above 30 inches, but is 50 okay? Is it too big? Do I have to go to 60? So this is not accurate. So even though I have this precise, I have to avoid everything that is between brackets, and that's also what INCOSE is recommending in the INCOSE guide to writing requirements. So once we have this defined, we can check here the same way we checked the first example. We can check each of the aspects, and here I'm relying on rules adapted to requirement statements, because in needs I could have some rationale, at least in the early stages again, because if we since we are running through various iterations, maybe the first one will be having needs expressed with a rationale here or with passive voice, and the more we work on these through the iterations, the more accurate it will be, and the less rules it will be triggering here. So if we move to something that is to a rule set that is adapted to need statements, then we would get something like this, which is a high quality statement. Coming back to the project data dictionary input, we can check using NLP the definition. So what is user credentials here? So we can see the definition of what user credentials mean. The same for management system, so responsible for processing, storing, communicating the information gathered. And here, if I show the example, if I write the requirement, so I would see how this is moving. So I'm introducing mistakes as long as I'm writing. So I'm writing a vague term, then I'm introducing brackets, and then everything is appearing, because that's where I'm. That's the critical step here. I have an article, I have a vague term. So here, is it a need? Is it a requirement? So again, if we go back to the discussion we had earlier, how to distinguish them. So here, the fact that I'm talking about the user, the fact that I'm using the passive voice, let's say, would be a good indicator, or maybe we have some keywords that would help. So whenever we have this question here, we might be able to check this. So here, this is what I get if I use let's say a need, a requirement tailored let's say a set of rules. And here, as you can see, we can display the synonyms, we can display the definition, and afterwards We can also do it the same for credentials. And then I will show in the end how these would apply if I apply another set of rules. So here the user is writing exactly the same requirements, but we are tailoring the rule for needs now. So using the rule applicability matrix, we are writing here a need instead of a requirement, and we have the rules checked for needs and not for requirements, and the result, of course, is influenced by this choice here. And finally, the final use case here would be, what if I write derived requirements from need statements? So if I have 3 requirements here derived from this need, of course, the need, as showed before, is considered a low quality. So I'm using the rule set for requirements, and then I will be using the same rule set to write requirements this time. So checking needs with a requirements rule set, obviously there's a higher chance of getting these kind of results. But then if I write the derived requirements, I get these kind of results. So for the second example here, of course, this is the rule set for needs. I'm writing in the same window, so I'm not changing the rule set here. And now I'm writing a requirement. So this is using the shall and the shall verb. We have a unit here, a proper unit. So obviously we are getting a high quality here. If I try to add something here, if I lose the let's say the path through the to the atomicity of the requirement, if I try to introduce something else, then just by writing and, we have the use of combinators here that is popping up. And of course, if I leave this unfinished, I have an open-ended clause. So of course, whenever there's a requirement, we tend to divide the need into several requirements with let's say a unique subject, a unique verb, and a unique action defined. And these would be the last one of the 3 examples. Coming back to the table here. So in this need, we actually have 3 derived requirements, one related to the action expected, one related to the size of the screen, and one related to the communication to the management system. So now, if you have any questions, please let me know, and I'll be glad to answer them.
Are you checking the chat as well?
So I have the chat box here open. So I see there are some questions here. So the first question here is, what is the relationship between a data dictionary and a data model? So I would say the data dictionary is let's say the container. So and we would define, let's say, the standards and the common reference we need. So to understand the context. So where does the information or the knowledge come from, and so on. And the data model would be let's say how we represent this information. So how it will be displayed to the users. So for example, one data dictionary would be the same data dictionary could be described in different models. So some users, some organizations might rely on modeling tools. Some others would rely on ontologies and so on. So that would be basically the relationship here. And the second question here is the rule applicability over the system lifecycle. So of course, here I'm talking about needs and requirements, but in our approach, we want to have these applied at different stages of the life cycle. So obviously, this is a framework for needs and requirements. But once you get the idea that needs and requirements have a different, let's say, preference for the rule checking, then we might apply this to needs that are for less critical or more critical systems. We have requirements for the subsystem, for the systems. Safety requirements maybe would have different rules. So you can, of course, increase the applicability also, and as I said, when you're defining the needs, the recommended rules can be skipped in the first attempt, and then we can apply them to see if I can improve the result of the checking. So the idea is to have a step-by-step approach. If I start right from the first attempt with the full set of rules, I might end up with dozens of rules, let's say dozens of remarks that pop up in the window, and I wouldn't know how to rewrite the requirements. So that's basically the idea. We want to increase the applicability step by step. So then, thank you, Lou, for the references to the presentations. So yeah, and regarding the elaboration here about the need statements that do not include shall. So yeah, here of course the applicability would be adapted to that aspect. So from the rules we implement some metrics, and these metrics would check or not check the shall verb. So we might allow should or other forms of expressing the need in that case. So the applicability would also apply to that. The next question is about the languages. So we do support up to 8 languages. So apart from English, we have German, French, Spanish, Japanese, Swedish, Italian, and Dutch. So if you need to have more detailed information about that, just please leave me an email. I will display my email after I answer the question. And then I see that someone wants to ask a question. So please feel free to speak if you want to ask the question.
Yeah, can you hear me?
Yes, perfectly. Thanks.
Yeah. Okay. First of all, thank you very much for this interesting presentation. I would like to come back to the first question about the relationship between this project data dictionary and data model, because you said that the project data dictionary is somehow the container of the data model, and this confused me a little bit, and most likely I have not fully understood that, and I would like to get it right. So if I consider the definition of data dictionary you have shown at the beginning, which comes from EBM, it says that basically it's a dictionary explaining, defining what are the data. And in my understanding, this is part of a data model, is describing relationship, the type of data, the meaning, and so forth. So it's part of a data model, and so when you said that, I thought that actually data model is bigger than the project data dictionary. On top of that, the name project also confused me, because if you say project, I think this dictionary should contain all, let's say, definitions using the project. But here we are, let's say, defining rules, relationships, terms, and so forth, only for, let's say, managing needs and requirements. So the scope is in my understanding, is more than the project. So in summary, during your presentation, I thought that you know, at the company level, we had to define, you know, a terminology based on a kind of a real concrete glossary or dictionary, so where terms are defined in order to be sure that people communicate correctly. And then we use those terms, we implement this into a data model that is used in developing systems. And in this case, a system that is used to check the needs and requirement statement quality, in which you do not only apply meaning to the terms, to the data using those systems, but also relationships, rules, constraints, and so forth. So once you answer that actually is the contrary, then I thought I have completely misunderstood the overall presentation. Can you say a few more words, please?
Yeah, so thank you, Francesco. That's a great input. So first, apologize for the confusion I had with the question. So let me rephrase that and make sure it's clear to everyone. So the data dictionary, let's say, is the as you said, the glossary and the relationships defined, and the data model will be let's say how we characterize these relationships. So what language do we use? So we can have an ontology model, OWL or RDF or any other language, or maybe you have just a glossary, a plain glossary. If you just stop at glossary level, you don't define relationships. And if I go back to your reaction on the organization versus project, if you check the presentation we did last year about ontologies, actually there are different levels in the way we define this data dictionary, which can have the form of ontology. So at organization level, we can define only the agreed upon terminology and glossary, and then maybe the relationships might be defined at system level. So it's not necessary that all the relationships are defined at organization level, or that all the dictionary is defined at project level. You have let's say as we call them, we have different layers in the way we define this dictionary. So the concepts might be defined at organization level. So the fact that we name this or that component might be common to all the projects, or maybe the standard we rely on, whereas the relationship that the components will be having depend, of course, on the system to be developed. So I hope that's making it clear.
We have another hand raised, and then we should let people know. You can go ahead and take a break if you want. Our next topic is 45 minutes after, but we can keep going with this one. Feel free to ask your question if you have your hand raised.
Hello, Mr. Yousfi, Matthijs Blom here. Thank you for your presentation. I just got a question about cost benefit analysis. Do you have any real life feedback, real life data? Because it seems like setting all these rules and compiling all the matrices that can become quite a complicated but well an important task, versus then just writing good quality structured requirements. I'm assuming that the benefit comes in on large projects when you need to manage large data sets. I'm just figuring, or I would just like to get a little bit more understanding of the benefits or the values of having all these rules and having the automated checker. Thank you.
Okay, so of course, apart from the inputs that are given in, for example, the system engineering handbook about the optimal effort for system engineering, there have been some studies that have been done to let's say to quantify the benefits of having system engineering activities and more specifically requirements engineering, and the fact that we have a proper let's say a quality analysis. And I don't know if you heard about the COSISMO model. So if this is if you're not familiar, we've been presenting some aspect about the COSISMO model, which is one way we would let's say assess the benefits of having let's say high quality requirements defined versus the efforts that you need to have this implemented. So if you want, we can I can send you some more information about this later on, and you can drop an email.
The COSISMO model, that would be of interest for me. But the question was not about the value of systems engineering, but particularly this what you demonstrated in the tool, having the ability to define rules in order to assist with the checking of good quality structured requirements. That benefit, I'm quite interested in seeing some real life data and some cost benefit analysis of that.
Okay, so of course, yeah, I can send you some data, or maybe communicate on some data after the presentations. Of course, these are not data that I can share here publicly because they come from let's say from some let's say some real projects, but more or less let's say generally speaking, we can as you said, the effort will be done in the beginning, and depends also on the thoroughness that you expect from the assessment. So if you just rely on the generic rules to check the syntax, you will get some benefits, not all of them, but this requires almost no effort from let's say the users, apart from getting the tools, because then the rules, the INCOSE rules are already implemented. So the only thing you have to do is just apply it to your documentation, to your specification, and have someone, let's say, review the results and decide whether to move to the next phase or not. So of course it's helping the decision. It's not replacing the human here. So when you check the quality of the requirements with such a tool, it's guidance for you to say, I'm on the right path, or I still need to correct this or that. But then you obviously have a review. And one of the main benefits, it's not here, I'm not talking about numbers, but the main benefit we did certainly see in over the past years is that the reviewers tend to focus more on the technological aspects, on the engineering aspects of the requirement, and less on the syntax and the way we have to express the requirements, because the tool is already doing it for them. So of course, depending on the way we write the requirements, depending on the industry or on the internal procedures, it's hard to say this is the benefit by requirement or by project, but at least generally speaking, we tend to see that you can focus more on the content and not on the way you shape the requirements. So I would say.
This is Lou. And adding to that, one of the I'm going to be talking about the guide to writing requirements on Sunday and Monday at the IW. The matrix that was presented, we've added as an appendices to the version 4 draft that we're working on. And so that's going to be reflected in the update to the guide to writing requirements. We're also exploring adding a new appendice concerning data dictionaries, ontology, and so on. We're going to look at a new appendice that goes into more detail, defining that. As far as the question about rules, my presentation on Sunday and Monday is going to be on characteristics. And one of the points I make is that to achieve the characteristics, following the rules is necessary, but not sufficient. There's certain things about, like one of the characteristics is that a requirement's feasible. And I could write the perfectly worded requirement statement that meets all the rules, but yet it's not feasible. It may not even be correct. It may have the wrong numbers in it, but there's no way for a tool to know that necessarily. So it's an aid. I've also heard that these rules, as people start using a tool that has these rules, the users actually get smarter. They get trained in the use of the rules, and they tend to not repeat the same mistakes over and over again. So one of the big benefits, if nothing else, is it allows people to write higher quality requirements, from the beginning.
Yeah. So basically, thank you, Lou, for the input, and of course, if you have any comments about the matrix or something that you would like to discuss, of course, we will be glad to do that. And just reacting on the last point about the rules helping you writing the first time. So what I was showing, for example, in the use cases of the demo is basically that you start writing, and then the rules are telling you this is requirement like or need like, and you have at least something that that is getting closer to a need or a requirement in terms of the characteristics. But as you said, there are some aspects that would need data from simulation or design aspects, and that's why we have this loop and these iterations. So some of the requirements have to be verified against some external data that we don't have at the time we document the requirements. So of course it's helping in the communication, as I said in the beginning, and make sure we don't express the same thing twice or contradictory things. So, but all the feasibility and testability aspects will come after, and usually the review helps also fill in the gaps that the tool can obviously not cover.
I know we had another hand raised, but we are reaching time. I'm sorry, Craig, do you have a quick question? Because we do need to make sure we get a little bit of a break before Henrik has his talk.
Yes, very quick. Does it make sense that the rule applicability matrix is tailored for an organization or project, or do you see the matrix as sort of standard across all organizations and projects?
So in that case, thank you for the question. I think it will be helping a lot putting this into context. The idea when we use the wording project data dictionary is that we would like this metrics to apply to a project. So of course, most of the guidelines would be derived from the organization level decisions, but it might be that in some cases, I don't know, you have a global organization and you're working on a project in let's say in Spain. So I'm located in Spain. So I'm going to use Spain as an example. Then the standard for drafting requirements, property requirements, will be to use the metric system. But then if you move to a project in the UK, you will be using the imperial system. So that would be an example of how we could tailor the project dictionary and the way we check the requirements. So in one case, one unit system would be correct, and the other one it won't.
Thank you. I'll follow up later. Thank you.
Thank you. I'm going to stop the recording. Just give me 1 second here.